Can you hear my voice? Yes. Hello.
Yes, sir, you are audible.
Can hear you.
Fine. Yes. So yes, in the yesterday demo session, just I was discussing about this. What is Apache Spark? Why Spark? Need for PySpark. So Spark versus Python and then Scala, right? Differences between Python and Scala. PySpark features, real life usage of PySpark, PySpark job market. Okay. So just observe this, right? Evolution of Spark. Evolution of Spark. Spark was developed by Matai Zaharia. In AMP lab, Berkeley. In AMP lab, Berkeley. In the year 2009. Spark was introduced in the year 2009. Hadoop was introduced in the year 2005. In the year 2009, right? Yes, and Spark was made open source. Spark was made open sourced. In the year 2010. Spark was made open source in the year 2010. And Spark was donated. Spark was donated to Apache Software. Yes. Apache Software Foundation, right? It was donated to Apache Software Foundation in the year 2013, right? Yes. This is something about this Spark, right? It was introduced in the year 2009. It was made open source in the year 2010. Spark was donated to Apache Software Foundation in the year 2013. So if I define Spark, what is Apache Spark? I define Spark in 4 to 5 lines, right? It is a open source distributed cluster computing framework with in-memory computing feature in parallel process style used for large-scale data processing. Parallel processing is going to happen. In-memory computing, distributed cluster computing used for large-scale data processing. Everything you are going to see in Hadoop also, but only this in-memory computing feature you're not going to see within this Hadoop big data Hadoop, right? Because of this in-memory computing feature, right? Spark has got very high speed. Okay. What do you mean by in-memory computation? In-memory computation, right? The main feature of Apache Spark, in-memory computation. In-memory computation means here data gets loaded into RAM and gets processed within RAM. Here data is divided. Here data is divided into partitions, and the partitions are distributed. The partitions are distributed across multiple RAMs, of multiple worker nodes. multiple worker nodes and are processed parallelly. This in-memory computation, the main feature, data getting loaded into RAM and getting processed within RAM. Data is divided into partitions, and the partitions are distributed across multiple RAMs of multiple work and are processed parallelly, right? Yes. So it is a general engine for big data analysis. It's a general engine for big data analysis, processing, and computation. Okay. So why PySpark? It is a Python API to use Spark. It is a Python API for using Spark. Python API to use Spark. I can say PySpark. Lightning fast technology. Which is designed for fast computation. Right? It's a lightning fast technology which is designed for fast computation and which is used for big data solutions. So it is one of the demanding tool among the data engineers to work with bigger data sets. It's used for distributed SQL and for creating data pipelines, ingesting data into databases, running machine learning algorithms, working with graphs, working with data streams.
What is distributed SQL?
So yes, if you see that we see like here Spark data objects, right? Data frames. The data frames, again, they are converted into tables. The data frames are distributed across multiple worker nodes and they're converted into tables, right? They're converted into temporary tables where you can make the data structured and you can perform pure SQL kind of querying. On the right? Data frames. And here Spark, Scala, and Spark means by default coded with Scala, and PySpark means we say like Python. So here, okay, need for PySpark means, see, PySpark means Python API for using Spark. So data is generated, right? This data contains hidden patterns, unknown corrections, market trends, customer preferences, and useful business information, right? To extract useful data from the raw data. So there are many tools already. I guess we have got many other tools, but for fast processing, right? For fast processing, this PySpark is one of the better among these, right? So it's one of the best scalable and flexible tools for big data, solutions. So combining Python and Spark is one of the efficient way for the world of big data. So Apache Spark community that came with this tool called PySpark, combining both Python, right? So PySpark is a kind of API, Python API, right? For using Apache Spark. And most of the Python and Scala, these two programming languages are mostly preferred. And Python is interpreted language and it's dynamic typed. So based upon what value you are assigning to it, if you're assigning integer, then integer variable creates. If we are assigning a float value to it, float variable create. If you're assigning a list is created. So based upon that value assigned, the variables created dynamically during runtime. But in Scala or Java, you should explicitly define, right, what is that type. So it's statically typed, right? Python has a huge community. It has got very huge community. It has got 89,300 built modules. That's got a lot of packages available, modules, inbuilt functions, classes, right? but Scala community is smaller, and Scala is just used for Scala and with Spark environment. No other environment using this Scala language. Python has got various usage, right? It is used as an implementation language in different high-end technologies, right? Not only like in big data environment, in data science, machine learning, deep learning, and writing automation scripts in IoT, in AWS DevOps, right? And in robotics, in various use cases for Python, and contains powerful libraries for machine learning, graph algorithms, right? It has got powerful libraries for this, especially for machine learning, graphs, and data streams. Scala has no such, but one advantage of Scala is this faster. Scala is faster than Python. Python is slower than Scala, right? Yes. Okay. Flink, there was another product introduced by Apache Software Foundation, right? Flink, which was dominating Spark in the initial versions, but it was weaker in the case of this data analytics. But from Spark 1.6 onwards, some powerful libraries was introduced by Spark, which was almost equal to Flink. But from Spark 2 version onwards, it came with very powerful libraries which almost dominated that Flink, right? Yes. So just I was this real life usage of PySpark in commercial sector, right? In commercial sector. So in real-time processing, right? This Apache, this PySpark can be used. Yes, a bank and other financial fields using this Spark in retrieving these various customer social media profile and analyzing these insights and extracting the information for credit risk assessments. And in healthcare, right, in just analyzing the patient's records along with this previous medical reports and identifying, right, mostly which patient is going to face the issues. And even for entertainment industry, right? So in online streams. So the popular online platform like Netflix using Apache Spark for real-time processing, right? It, I said, it is just going to process 450 billion events per day that are streamed over these server-side applications. And for trading and e-commerce side also, right? Trading and e-commerce like Flipkart, Amazon, all this, they are using Apache Spark for advertising. Yes. Even that other websites like Alibaba provides enhanced customer experience and overall performance, right? Yes, and even for tourism industry, yes, Spark is used to provide advices to millions of travelers. So these are some examples right where the Spark is used. And as I said, Spark has multi-language support. Spark has multi-language support. Spark can be coded with Spark can be coded with Spark can be coded with Scala. Default, it's a default language. It's Python. Spark can be coded with Python and Java and or language, multi-language support. Or language. Or language and Java are very less preferred, but Scala and Python are mostly preferred. Default Spark by default written in Scala. Scala is the native language of Spark. See, if you see the execution generations, right? Yes. They were MapReduce. It is also one of the execution model parallel. It is designed for parallel processing. MapReduce, Sage, Spark. MapReduce, right? It is designed for parallel processing, but it has got outdated, right? And Tej and Spark, if you see the comparison between Tej and Spark, right? Both follows, see, both follows DAG model. Both follows DAG model. DAG model means directed acyclic graph. Both follows DAG model, directed acyclic graph model. But Tej doesn't support in-memory computing. Tej doesn't support in-memory computation. But Spark is in-memory computing system. Spark is in-memory computing system. Spark has got very high speed as compared with Tej because of this in-memory computation, right? If we see what are the other in-memory computing systems. Yes. We have got SAP HANA. It is also in-memory computing system, right? If we just compare this HANA and Spark.
Sir, in-memory computing system means process in the memory, like that.
So just here I have typed, right? What is in-memory computing? What is in-memory computation? So here, what is in-memory computation means data gets loaded into RAM and gets processed within the RAM. Data is divided into partitions and the partitions are distributed across multiple RAMs of multiple worker nodes and are processed parallelly. So storing within the RAM level and processing within the RAM level, right? In-memory computation. Here, HANA and Spark, right? Both follows in-memory computation. Both follows in-memory computation. But HANA is not distributed. But Spark is distributed RAM. But Spark is distributed RAM. So for huge storage, right? Hadoop. For fast processing, right? PYSPARK. Combinedly, yes. Both can, okay. Combinedly, both can store and process huge data, right? Yes.
Do these computings comes with the software? Like, do we have to explicitly select these properties, how the program should run, like Taze or MapReduce?
No, it is internally available, right?
So it comes by default. I don't have to enable.
Yes.
Oh.
PYSPARK.
Sir, both can store and process use data, but PySpark cannot store the data, right? Or you can,
Combinedly means both.
okay.
Combinedly both.
Okay, we can use store in Hadoop and we can process by using Spark. Yeah.
PySpark is mainly used.
Sir, could you please tell about the MapReduce or Tej like that? What's it?
Okay. So yes, Tej and Spark both are got directed acyclic graph model, DAG model. But one drawback, okay, what is this DAG model? We'll be discussing totally in the Spark, right? But both has got DAG model, but Tej doesn't support in-memory computation because of that. Spark compared Tej and Spark comparison, Spark has got high speed. So Spark has got high speed. Why high speed? Because of Spark has in memory, but it doesn't have in memory. When HANA and Spark compared, both are in memory, but HANA doesn't have distributed. Now I'm comparing Spark technology with other technologies in the market, right? Why only Spark has got that very high speed? Any other in-memory computing? Yes, available, but it's not distributed. Why? Why? Because, for example, HANA, if you got a 10 TB memory, 10 TB memory available, daily 1 TB is coming. So maximum 10 days it can store. 11th day, if you want the first day data, we need to erase it. 12th day, next second day data, we need to erase it. Means, but Spark is a distributed RAM. We can keep on increasing, right? So if you want, if your data is increasing, we say commissioning and decommissioning, right? So if you want to keep on adding the nodes, if your data is increasing, we will be increasing the nodes. Right? PySpark is mainly designed for batch applications.
Means not a fresh data.
Hmm.
Means where data is not online.
Batch applications means user non-interactive applications. User non-interactive applications, which user doesn't give the input. User doesn't give any input, right? Everything happens in the background. Batch
Means that data is not a production data like that.
batch application. Okay, so if for example, user non-interactive application means, for example, if you take any application, right, online banking, right, where user has to give the input, source, destination, right? It's an online application. For example, if you take railway ticketing PNR status, right? Today your waiting state is 200. After 2 hours, it became 150. Tomorrow morning, it became 50. Tomorrow evening, it got confirmed. Means user doesn't give any input there. User doesn't have nothing to do. It's everything happening, right, in the background. User doesn't give any input. User interference is not required. User non-interactive applications. For example, credit card statements generation for millions of customers. User doesn't have anything to do there. Automatically, the statements are generated for millions of customers. So that is batch applications. Means batch millions of, even for mobile bill generations, right? For millions of customers. The user input is nowhere required there. Most of these banking and financial applications are batch applications where user doesn't have any interference, right? Doesn't give any input. And iterative algorithms. So PySpark is mainly designed for batch applications, iterative algorithms.
Iterative means repetitive.
Yes. See, most of this, if you say data science or this machine learning algorithms are iterative in nature. Whenever you apply, you will be getting some kind of error. It won't be that accurate. So again, we keep on applying for again and again on the same input data until the error becomes 0. Means iterative in nature. Yes. Interactive. So it's mainly designed for batch applications, iterative algorithms, interactive queries. Like we say, like Spark SQL, right? SQL kind of querying, and for streaming.
Interactive queries means use of SQL there like that.
Yes, querying the data, querying, right? So where we are making the data structured and performing some kind of querying on the data. Yes, and for streaming dates, for streaming, right?
Streaming means
Live streaming data, right? Data which keeps
okay.
on incrementing, which keeps on generating, keeps on generating. For example, if you take a, if you have downloaded any file from a website, think a movie you have downloaded. Morning, if you see, right, if the size was 2 GB, the movie size. Afternoon also the same size, night also the same. After 3 days also the same size, the downloaded file, like a moving file. But if you see any other like streaming data, like if you think that CCTV or webcam, right, morning the file size was 2 GB, afternoon it became 4 GB, evening like 6 GB, after 3 days it became 20 GB, right? Means keeps on generating, right? At one events keeps on generating. So such kind of data, right? Even very fast processing technologies like Spark can process it at one time. The events are generating the other times, and even using Spark, right? Using this Spark streaming, right? We can create micro batches, quick updates for every 10 seconds, providing updates, right? For these things.
We can say data load like that.
Streaming is nothing but live streaming, I can say.
So means incremental data is going there.
Which keeps on generating data, which keeps on generating. It
And
won't
no
be
truncation.
like, it won't be like static data. Events keeps on generating. Events keeps on generating.
Means initially 10 records, then 10 tweet like that. Initially means 10 records there. After some time it will 20, 50 like that you are saying.
Example like your chat messages.
Okay.
Spark is okay. MapReduce and Spark. MapReduce and Spark. If you see that the comparison between MapReduce and Spark. MapReduce drawbacks. So MapReduce, it's one of the it's very well designed, right, for fast processing, for parallel processing, right? But the drawbacks for this MapReduce drawbacks. Transformations cannot be reused. Transformations cannot be reused. Yesterday I was just briefing you, right? Transformations cannot be reused here. But in Spark, transformations can be reused. In Spark, transformations can be reused, right? Transformations can be reused means already executed transformations, that output I can take it. And this is bad for iterative algorithms, bad for iterative algorithms. Bad for iterative algorithms, right? Yes. So most of these machine learning algorithms are iterative in nature, but this MapReduce is bad for iterative algorithms. So that's why Spark is mostly preferred. So it's not a flexible parallel process. MapReduce is mainly designed for parallel processing, but it's not a flexible parallel process. Because MapReduce, first mapper and reducer, two mainly phases are there, mapper phase, reducer phase. But this mapper phase and reducer phase both cannot execute in parallel. Both mapper phase and reducer phase both cannot be executed in parallel.
Means first mapper execute, then reducer.
Mapper phase executes, that output is taken by the reducer. Sequential execution is say. But mainly this map reduce is mainly designed for parallel processing, but mapper after that reducer, map reducer, mapper and reducer sequential execution is going to happen. And that too, it's slow processing. Slow processing, right? Yes. Okay. Spark and there is another component called Apache Pig. Apache Pig, right? Yes. Both are data flow languages. Both are data flow languages. Both are data flow languages, but in Pig. But in Pig, the entire data flow is converted into one map reduce job. One map reduce job. But again, map reduce is bad. Just before we discuss the drawbacks of map reduce, the entire data flow is converted into one map reduce job. But again, map reduce is bad. Both are data flow languages only. Okay. Now, based on this, right, Spark features and advantages. Spark features and advantages. Spark features and advantages. First thing is in-memory computation. In-memory computation. As compared with Sage, it's missing. In Sage, we doesn't see this in-memory computation. Second, distributed execution. Distributed execution, which you are not able to see in HANA. The drawback in HANA, right? For example, compared with MapReduce, flexible parallel process. Flexible parallel process. Flexible parallel process, right? As compared with MR, it's not a flexible parallel process. Transformations can be reused. Transformations can be reused. Good for iterative algorithms. Good for iterative algorithms, right? Machine learning algorithms, right? High speed. High speed, right? Yes. high-speed processing, multi-language support, supports multiple languages like Python, Scala,
Sir, what is benefit of iterative algorithm?
or language. Iterative algorithms, good for iterative algorithms means if you are dealing with machine learning, right, data science, right, this iterative, good for iterative algorithms. So MapReduce was bad for iterative algorithms. So we used to have Mahout, a component called Mahout previously, but when Spark has introduced, powerful libraries for machine learning were introduced, right? So for this, most of the ML algorithms are iterative in nature, right? So Spark is also good for those kind of algorithms. For example, just a small example, iterative algorithms, a small labor example I will give. Yes. A person, his age is 30. I'm asking you to predict the age of that person. So your prediction first time it was 25. Later it was 27, 29. Later you predicted as 30. Means you have taken nearly 4 iterations, right? Means sometimes may take 4 or sometimes it takes 10, 20, right? Iterations predicting. If more number of iterations, whenever the current accuracy is, whenever you get the correct accuracy, we'll be stop iterating, right? Same way here. Whenever you perform any types of algorithms, ML algorithms, right? You will be getting some error. When the error becomes 0, right? We'll keep on iterating, right? Until multi-language support, yes. Supports advanced analytics. Supports advanced analytics. Supports advanced analytics like ML, for machine learning, for graph, and for data streams. And it is lazy evaluated, right? Lazy evolution we say. Is not active evaluated. When action is performed, when you perform action only, then the data flow executes, otherwise don't execute. On demand executing the data flow. That is lazy evaluated, right? One of the important feature of PySpark. I'll just show you some examples on this lazy evaluated and persistence. Has got persistence feature. So persistence feature. Already executed transformation output can be reused. If persistence feature is available, already executed transformation output can be reused. Advanced analytics like machine learning, graph algorithms, DS streams. So partitioning, already the data will be partitioned across multiple and will be stored across multiple ramps of multiple worker nodes, and already no output in memory computations. And fault tolerant, powerful fault tolerant model. Powerful fault tolerant model. Whenever as you are using multiple machines, your data data is stored across multiple RAMs and processed by multiple RAMs. But suddenly, if any machine goes down, there'll be a data loss, right? That is. Then how it can Spark has got the capability of recomputing the lost partition. It has got the capability of again rebuilding the lost partition, right? Yes, that means that fault tolerant model, powerful fault tolerant model. If any machine goes down also, again it has got the capability of rebuilding the lost partition. Okay, just I'll show you one examples on this lazy evaluated, persistence, and powerful fault and transformations can be reused. For example, there is a data flow like this. So here in Spark, everything we say like RTDs, right? So for example, this R1 I'm saying, its output is taken as input by R2 as input. So just the flow from R to R3. This output is taken as input by R3. From there, R4, R5, R6, R7, R8, R9. So totally this is the flow 1. This flow 2. The second one is what? Flow 2. The third one is what? Flow 3. Flow 1, flow 2, and flow 3. First one, flow 1. If you see this flow 1, right? R1, R2, R3, R4, R7. Flow 2 is R1, R2, R3, R5, and R8. Flow 3, 3 flows are there. R1, R2, R3, R6, R9. So if I want to execute the flow 1, right, I need to make action on R7. At the last one on R7, if I make some R7 dot action, then the flow executes from its root means R1. From R1, R2, R2 to R3, R3 to R4, R4 to R7. So all these RTDs, all this, right? We say these are the Spark data objects, we say, right? From R1, R2 got created, from R2, R3 got created, from R3, R4, R4, R7. All this won't be loaded into RAM at a time because RAM cannot accommodate all this. Already each one will be a bigger data value. So first R1 gets loaded. The R1 output will be taken as input by R2. When R2 is loaded into the RAMs, observe carefully here. All these, how many 5 are there? All these 5 cannot be loaded into RAM at a time. If all they are loaded at a time, then RAM capacity is not that much, right? Already there will be bigger data values. So first R1 loaded. Now once R2 is loaded, once you got that output, once the output of R1 is collected, once R2 is ready, R1 gets removed. Yes, R1 gets removed from the RAM automatically. Once R3 is ready, once it has taken the output of R2, now once R3 is ready, R2 gets removed from the RAM. Once R3 output collected by R4, and once R4 is ready, R3 gets removed. Once R7 is ready, right? Yes. R4 gets removed from the RAM. And next, once R7 output is collected, R7 also gets removed from the RAM. Now, which is present within the RAM? Now, what is present within the RAM? Now, what is present within the RAM? Nothing.
R7 output. like that.
No, or everything. R7 is removed from the RAM. Everything, yes. Nothing is in the RAM. Nothing. RAM is empty. Once the total flow executed, nothing will be within the RAM, right? Now, once the RAM is cleared, right, you can just execute the next flow, the other flow, right? The other flow can be executed. R1, R2, R3, R5, R8, right? R1, R2, R3, R4, R8. Now, once one by one, once R1 is loaded, R2 one also is ready, R1 gets removed. Once R3 is ready, R2 gets removed. R5 is ready, this gets removed. Once R8 is ready, this gets removed, right? Yes. Now, what is there in the RAM? Nothing. Once this R8 output is collected, then R8 also gets removed from the RAM. Just observe this flow 3. Yes, for each flow, it's reading use data again and again. Yes, 1 second. I'm coming to it. Flow 3 also, right? R1, R2, R3. After R3, R6, R9. Yes. Once R1 loaded, next R2. Once R2 is ready, yes. R1 gets removed. Once R3 is ready, R2 gets removed. Once R6 gets loaded and ready, this gets removed. When R9 is ready, R6 gets removed from the RAM. Once this output is collected, then R9 also gets removed from the RAM. So no RTDs in the RAM now. This is what happening within this. All right, I'll discuss what is an RTD, right? Yes, but in what is that you're observing in all the 3 flows? R1, R2, R3. In every flow, these first 3 steps are common. Once the flow 1 executed, already. So here, all the flows again and again, they are executing from the starting. Again and again, they are executing from the starting, right? Yes. So instead of that, the flow, the RTDs whose output is commonly used by multiple flows persist. If you persist this, right? What happens if you persist this, right? It will be remains. Once the flow execution finished, no need to already R3 persisting means making this available in the RAM, even though the next one is ready. even though the next one is ready. Okay. So here directly when R3 is available in the RAM, we no need to start from R1 directly from R3, R5, this is your flow. Here also no need to execute this from directly R3 is available in the RAM. Directly you can start from R3, R6, R9. Right? Yes. So these many steps are decreased. For example, if you have taken R1, R2, R3, R50, from R50, R60, R70, R80. Means first 50 steps are common for flow 1, flow 2, and flow 3. So if you persist this R50, second flow, third flow, if you're executing, no need to execute the first 50 steps. From R50 to this flow is enough. The last flow also R50 to this. So if you are persisting means making this available in the RAM, even though the next one is ready. That's what this is the feature we see here in Spark. Transfer already executed transformation can be reused in the flow 2 and in flow 3. Already executed transformation can be reused. What time this persistent data will get removed? Yes. How can we remove this persistent data? Means see, for if you want R50 dot persist, we say. If you want once the flow execution is finished, here what happens? Once the flow 1 executed, only R50 will be in the RAM. Second flow also execution finished, R50 will be in the RAM. In third flow also, once the total execution, R50 only. But if you want to remove R50 after your total executions are finished, unpersist it. Once your total execution finished, if it doesn't want that to be in the RAM, you can unpersist it. Unpersist. Persist means make it available. Okay, this is the so these three things, right? Lazy evaluated means once the action is performed, then only the flow execution. Persistence feature, then only it can reuse the already executed transformation. Powerful fault tolerance model, if any machine, right? Yes. If you're not persisting means again the flow will be executing from the beginning. Yes. The flow executes from the beginning. Yes. Ajay Patekar, right? Arpan Tiwari, yes. If you are not persisting, right, the flow executes from the starting. The 50 steps again, second flow also, the 50 steps again they need to re-execute. Means here 50 steps are decreased, right, in the flow 2 and in flow 3. Already in the flow 1, you have executed all the 50 steps. The 50th step output you can take and you can compute the remaining steps, right? In the third flow also, right, R50 to R80. Yes. Okay, that's fine. So what is the Spark data objects and how it is going to be divided into partitions, how it is going to get distributed, how it is going to be computed, what are the steps involved in this computation, right? And what are the many inbuilt transformations available, like filter transformations, merging, grouping, sorting, all this data will be in HDFS. It's just a need to reprocess it. So yes, it takes the data and it's going to it distributes across multiple. See, data it takes and it will distribute across multiple RAMs. Once the execution finish, you won't see any kind of data there. But the final result, if you want to store back in file system, right? You can store it back in the Hadoop distributed file system. So here I can say one motivation towards Spark, right? So if you motivation towards Spark. So already Yahoo has conducted a test to check the speed of various databases, right? It has taken a table of 1 TB. (100 TB) consisting of 1024 columns. Task is sorting based on 16 columns. So what is the time taken, right? Time taken for performing this, right? This, if you talk like Oracle, it has taken nearly 3.5 days. MySQL, it has taken nearly 6 days. Teradata, right? Teradata, specialized database used for data warehouse purpose. Yes, Teradata, right? It has taken 4.5 hours. Netija, another specialized database used for data warehouse purpose, 3 hours. Finally, right, Hadoop, it has just taken 3.2 minutes. 3.2 minutes, right? But in the latest version of Hadoop, it has just taken 1.2 minutes. But Spark, the name itself saying like 100 times faster. 100 times faster than Hadoop. Hadoop already has taken 1.2 minutes as compared with the other databases, right? Spark is 100 times. Yeah, Hadoop means MapReduce. Hadoop means MapReduce. MapReduce execution happens. Spark 100 times faster than Hadoop MapReduce. Yes, that's why motivation, right? See the speed of Spark, right? As compared with any other technologies, right? Very high speed. So today, like industry also expecting the very high speed, right? To get quick results. So Spark is most of these ETL kinds of projects migrating towards this Spark environment, like using PySpark, where we can achieve very high speed, right? So yes, and here the thing is we need to maintain like huge RAMs required. Yes. Okay. So many built-in transformations Spark is providing. Everything we'll be discussing is many working examples, right? Like, see, this is the core structure, right? By Spark session, Spark context, parallelizing, repartitioning, broadcast variables, operations on RTD, directed DAG, actions and transformations, RTD computations, RTD persistence features in memory only, memory serialized only, disk and serialized, memory and disk only, PySpark core computations, creating Spark objects, increasing the number of partitions, aggregations over structured data, groupings and aggregations, different types of groupings, single, multi-groupings, process by group by key, reduce by key, various actions and transformations, various actions and transformations, right? Yes, all these are the different types of transformations. PySpark SQL data frames, various data frame APIs. Right. frames, right? Spark SQL totally on data frames. Spark SQL on data frames. Yes, Arpan Tiwari, right? Spark SQL on data frames only. Various data frame APIs. So show, struct type, row class, column class, select, collect with column renamed, where, filter, drop duplicates, order by, group by, join, union, UDF map, flat map for each, fill nulls, pivot, partition by, and PySpark SQL functions, aggregate functions, window functions, date and time JSON functions, right? When expr lit, split, substring, translate, overlay, to date format, date difference. Yes, all these are the inbuilt functions. Map keys, map values, sum, average, dense rank, percentage, from JSON to JSON, JSON tuple. All right. And PySpark external sources working with SQL statements, I have integration, MySQL integration, right? Narrow and wide. Yes, writing data back to some external sources, creating of tables from data frames, deployment mode, local mode, cluster mode, PySpark applications, states and tasks, drivers and executor, building Spark applications, deploying Spark performance tuning, right? And integration with Kafka and streaming concepts and machine learning library. So everything in brief, it will be covered, right? Like 10 weekends, it takes like 10 weekends batch. So you'll be getting the recorded video of every session, clear notes, RTDs in detail or just overview means. Yes, Arpan Tiwari. Yes, RTDs will be discussed in detail, right? RTD computation, right? RTD computation. In this operations on RTD, directed RTD actions, transformations, RTD computation, RTD persistence and persistence features. Total RTD computation will be discussed. Later, I'll come to this data frames. Yes.
Hi, sir. Means we are going to work any project after this course, like you are going to discuss or something.
So at the last, I'll be discussing one flow, right? Project flow.
Okay. Means any specific project, like means will you give any code and all? No, right?
Yes. Just I'll be explaining the flow of the project.
Okay.
This
And one
okay.
more, sir. Here, what we are using, sir? ID or normal?
So yes, I'll be showing. Yes, I'll be showing you how to work within the Linux environment. So I will be providing you the VMware for it. And for Windows, within the Windows also, I'll show you how to run this PySpark within the Windows environment and execute that. And IDs like I'll be using Jupyter Notebook. I'll be showing you in Jupyter Notebook ID, right? And
Okay.
also like Spider ID also. And also on PyCharm ID also I'll be showing you how to
Okay.
run this and what all that libraries required, how we can import it into that PyCharm.
Okay.
That's I'll be discussing. Everything about the software, not a worry. Everything I'll be showing you, right? I'll be forwarding you to your Google Drives.
Okay. And sir, one more doubt, sir. After this course, will you get, means if we practice well, then can we work on like experience, like just
See, one second. One in PySpark is a which has got high boom in the market today. If you can check this PySpark jobs, you can see, and even if you see the packages for that PySpark as compared with other technology, it's very high packages for this PySpark. Same way, they'll be expecting some kind of technicals from you, right?
Yes.
You need to have some kind of command within the technicals, right? So
Yeah.
everything will be discussing about all the PySpark actions, transformations, everything, right? Given by PySpark.
Okay. Why? Because after this course, it means we will also practice. But after that, if they give any means work and all, we can manage, right? Then if you practice well and all, right?
Yes.
Such kind of we can. Yeah.
Yes, Arpan Tiwari, right? At the last, I will also give knowledge on Kafka.
Not. Okay.
Kafka streaming, right? Yes. Yes. Okay. So fine.
No, sir.
Yes,
do,
yes.
Like, do you recommend any platforms to actually practice? Like, Is there any website we can get some examples or something to practice on this?
Lot of
While you're
examples,
explaining.
lot of examples I'll be providing you, right? And I'll be giving some assignments tasks to work with. Fine.
Okay.
And also I'll be showing you how to work within this Databricks environment.
Sir, also Kafka or any real-time projects we will be doing here?
So already it takes a lot of time to cover all these things, right? All this whatever we are discussing, right? RTD computations,
Okay.
data frames, APIs, various integrations, all these things, right? Kafka is a separate thing, right? Kafka is a separate thing. But even I said I'll be giving knowledge on this Kafka's training.
With respect to PYSPARK, are we doing any projects, sir? Real-time project?
I said right at the last, I'll be showing you one project flow.
Okay.
Okay. So yes, just if you see in the 1 second. If you see in the chart panel, right, you can see a message given by this online team regarding this enrollment process. If you are interested, you can just go through that payment process. We've got different payment process. And also they are given the contact details of the online team, right? If you've got any queries, you can just contact, and this course content and the test demo video link is given, right? Today's video also, it's just the link will be provided to your mail IDs, right? Yes. Fine.
Sir, timings are 6:30 to 7:30, sir. Saturday, Sunday. Means it will be extended, like
6:30 to nearly it will be for 8:30.
okay, 7:30, 8:30. Okay.
Fine. So try to get enrolled, right? For getting the link. So next Saturday the link will be changing, right? So for getting the link and for get enrolled, the link will be forwarded to your mail IDs by the online team. And also don't forget to share the screenshot of your payment if you're done with the payment, right? Then only they'll be forwarding you the screenshot. That is that mail, right? That link, meeting link. Yes, fine. So next week the link will be changing. So get enrolled. So I'm stopping for now. We'll continue in the next day, right? At 6:30. Fine. Okay.
Sir, one more doubt. The recorded session, how long it will be active?
Really like 6 weeks to 6 months to 7 months.
6 months, huh?
6 months.
Yeah, okay.
So you're planning to keep the same schedule, right? You're not going to change any timings.
No. Timings won't be changed.
Okay.
Sir, after the end of this course, 6 months or from now 6 months?
From now 6 months. So later again, if you want to extend that, you can just you can need to talk to with that office, right? Front office. If anyone who wants to just extend that videos, right? From now onwards, it will be from 6 months, right?
Hello.
Yes. Yeah. Any other query, right? So the sessions will be interactive sessions, right? At any point of time, you can ask queries during the session. During the session, you can ask queries, and whatever I will be typing, you will be responding with that result, right? Like that kind of interaction. It's not like me just speaking for 2 hours. That it will be interaction from both the sides. What will be the expected results, as it's a data flow, right? Right. What will be the output for the flow? Yes. So if I'm done with your queries, I'm signing off for now. Meet you next Saturday at 6:30 p.m. right? Yes. Thank you all for your time. Thank you. Meet you in the next session. Bye.
Thank you.